All right, here we are at Unit 8.1, Distribution with Polynomials. We've talked about distributing before in our last semester, but we'll go over this and we're going to add a little more to what we learned before. So we're going to start with some vocabulary, coefficients, constants, and terms. All right, we talked about coefficients in our last class when we did exponent rules. So a coefficient is a number that multiplies a variable. All right, it's always written in front of the variable. So I labeled the ones that are green. Those are the coefficients, 2 and -4. All right, so if there's a negative, that will be part of the coefficient. All right, constant is a number by itself. There's no variable with it associated. Okay, so 3 would be the constant. And then we also have term. Term is a number, variable, or both. Terms are separated by plus or minus signs. So I marked those by using red. So we have 3 terms. One term is 2x squared, another term is -4x, and 3 is another term. So we have 3 terms. All right. So last semester we also learned about combining like terms, so let's do a quick review of that. So like terms means that they have the same variable and coefficient, or exponent, sorry. So same variable and same exponent. So let's look at some examples. 2x plus 5x, can we combine these? Are they like terms? So since they have the same base, we'll use a different color, same base, and they have the same exponent. Here the exponent would be 1. But usually we don't write that down. So here we have the same base and same exponent, so we can add those together. So that gives us 7x. Okay, and the base and the exponent will stay the same. All right, I've seen some students that say, oh, it's going to be now x squared because we added 2 x's. So we don't do anything with the exponents. We're just saying we have 2 x's, or 2 x's, and then 5 x's. We're going to add those all together, and that gives us 7 x's. Okay? Another way you could write this would be x plus x. That's what 2x is. And then we're going to add 5 more x's. So, oops. 1, 2, 3, 4, 5. So we're just going to add all of those together. We did problems before where we had like x to the 2, and remember that's like x times x, right? So if that helps. Anyways, so those have like terms, and then here let's look at another example, 5x squared plus 3x. Those are not like terms because, yes, they have the same base, but they have different exponents, so we can't combine them. All right, so let's just do a quick review, doing a couple problems using like terms. I also want to mention that we should always write or list terms in order from largest to smallest, ending with the constant. Okay? So, for example, if we want to write them from highest to lowest exponents, let's start by looking at the highest exponents. We have x squared. All right, that would be the highest exponent. So we're going to combine like terms because they have the same base and same exponent. We'll do 5 minus 3. That gives you 2x squared. All right, our next highest exponent would be the x's. So 2x minus 6x gives us -4x. And then here we have our constant. All right, so that would be our answer. The exponents are listed highest to the smallest, ending with the constant, and we'll be good. Okay, I always like to write lines underneath mine just to show which ones are like terms. And that way, when I get to the end, I know that everything is being used. We don't forget any terms. All right, so I'd like you to try these ones. You could pause and come back to it, or play when you're ready. All right, so here we have the highest exponents. We have k to the 4. There's no other k to the 4s, so we'll just write those down. We don't need to combine. Our next would be k to the 3. and that's all there is 1k to the 3. And then we'll look at the k's. We have 12k plus 5k plus k. So again, we're just going to add those. That'll be 12 plus 5 plus 1. And that would give us 18. So plus 18k. Again, it's in order, highest to lowest, and we're good. That's why I like to do the biggest exponents first when I'm combining, because then it's already in the correct form. So here's the highest, m squared, and then the next would be negative 7m, and then we have two constants that we're going to combine like terms. That would give us 6 plus 8, gives us 14. Okay? And then we have d. Highest exponent would be negative n to the third. And then we have our squared terms plus 2n squared. And then we have our n's. 15 minus 8. That gives you positive 7, so plus 7n. And then we have our constant plus 7. Okay. All right. So let's do some, well, it says, I'll just read it. This semester, we have focused a lot on polynomials. In order to fully define a polynomial, there are some more terms that we need to know. Okay, so we can classify polynomials by the number of terms. So a monomial has one term. So for an example, we have 3x squared has one term. Binomial has two terms, like x to the third plus 2. Those would be two terms. Trinomial is three terms. Again, here's 1, 2, 3. And then polynomial, just means many, so many terms. If we have more than 3, what we're going to do, like for example, here we have 5 terms, 1, 2, 3, 4, 5. We would just say it's a polynomial with 5 terms. Okay, so the first number of terms, 1 term, 2 terms, 3 terms, we're going to call those special names like monomial, binomial, trinomial. And then anything above that, like 4 terms, would be a polynomial with 4 terms. Or 5 terms would be a polynomial with 5 terms. All right? Another tool to help us simplify is called the distributive property. To distribute a term is to multiply it by every term inside its parenthesis. So here, the distributive property would be to multiply the 9 to the 1, and then the 9 to the negative 8x. So 9 times 1 is 9, and then we have 9 times negative 8 gives you negative 72x. And again, we should write highest exponents first, so negative 72x plus 9. All right? So perhaps try and do some of these. Pause and come back to me when you got it. So here we'll distribute. Negative 9 times 9 is negative 81n. And then negative 9 times 8 is negative 72. Right? Here's another example. Again, with PEMDAS, we need to make sure that we do multiplication first. So we need to distribute the negative 6. So we still have 4. And then we're going to do negative 6 times 9. That gives us a negative 54a. And then negative 6 times a negative 4, negative negative, gives us a positive. So positive 24. And then we'll just combine like terms. 4 plus 24 gives us 28. And you're good. Okay, so just a reminder, I think in some of our classes we've had issues with people getting to this point where it was just what's right over here. That when we're combining like terms, we're just, adding. These are like terms, we're going to combine them. I have seen some students that maybe try and subtract 4 to both like that, but you can only do that when there's an equal sign between sides. So we subtract 4 to both sides to keep it balanced, but here this isn't an equation. We don't have an equal, so we're not going to subtract 4. Otherwise, we'd be really just like magically subtracting 4 and minus 4 give us minus 8, and we're just magically taking off 8, right? And that doesn't, it changes our expression, so we can't do that. So make sure you catch that if you ever do that, okay? All right. So if there's not parentheses, then we're just combining like terms on, and we don't have to do any adding or subtracting to both or whatever, if you know what I'm trying to say. All right. Here, same sort of thing. Pause and see if you can do this. 7 times 8 is 56. And then we've got 7 times 8 again, so plus 56k. And then we have plus 1. Combine like terms will give us 56k. And then our constants, that gives us a plus 57. Again, make sure we have the highest exponent first, and then our constant at the end. All right, here's just some other examples. I don't think I went over all of these in class, but just in case you want extra examples. Okay, we'll distribute, give us 4p, distribute, that gives us 12. Here again we have a negative 2 we need to distribute, so that gives us a negative 10p, and a negative 2 times a negative 3, that gives us a positive 6. So negative negative is a positive. And I think in our class last semester, a lot of the mistakes here was that people only distributed the 2. They didn't distribute the whole negative 2. Okay, so make sure you be careful with that. Combining like terms, highest exponents is just the p. So that gives us 4 minus 10, gives us negative 6p. And then we have our constants, gives us plus 18. All right, and then we have f as well, same deal. So 5 times 3 is 15. 5 times negative 7 is negative 35x. Distribute the negative, negative 1, and distribute a negative times a negative gives you a positive 6x. And then we'll combine like terms again. So these are like terms. That gives us a negative 29x. And then we have our constants. That gives us a plus 14. Okay, so please when I do these, try and do as many as you can by yourself. You'll learn so much more if you try and do it yourself, even if you make it wrong or make a mistake. Okay, you'll learn even better. Okay, all right, so example 3, multiplying a monomial and a binomial. All right, so before we were just basically distributing constants, just numbers. Here we're going to distribute number and variables. All right, so you can do one at a time, like 2 times, if you wanted to say that would be 1, we'll multiply the coefficients. 2 times 1 is 2, and then we can distribute the x times x, that gives you x squared. And then we can distribute the 2, that gives us a negative 20, and distribute the x, that gives you an x. Okay, usually I don't do it that way. Usually what I would do, let me just do it one more time. We just distribute the whole thing, 2x times x, that gives you 2x squared, and then 2x times negative 10 gives you a negative 20x. Okay, so maybe pause and see if you can do BC. Wait, where's C? Oh, it's over there. B and C, maybe we'll go back and I'll do D, okay? All right, so here we'll distribute. That gives us 9 times 6 is 54x, and then 9x times 5x. Well, 9 times 5 is 45, and x times x is x squared. And then we just need to write them in the correct order, highest exponents first. And you got it. Okay. Here C, we have a squared times a. That gives us a to the third. Again, we use these rules in exponent rules that if we had something like this, that if they have the same base, we're going to add their exponents. So that's like a to the 2 plus 1 equals a to the 3. Okay? But you're welcome to just do that in your head if you can. Okay? Or if you want. So a squared times a is a to the third, and then a squared times negative 8 gives you negative 8a squared. All right, let's do this one together. Here we're going to distribute this whole thing over. So negative h to the third times negative 2h. All right, well, we have a negative negative, that gives us a positive. And then we have, and if you wanted to put a 1 there, you can. 1 times 2 is just 2. Or you could say negative 1 times negative 2 gives you a positive 2. And then we've got h to the third times h. That gives you h to the fourth. All right, and we'll distribute the next one. Negative h to the third times 5 gives you negative 5h to the third. Distribute the x. So x times negative 5x to the x squared gives you negative 3x to the third. And then we'll distribute that to the 4, gives you plus 4x. All right. And then the last one, we have a negative x times negative 3x squared. Well, that gives us a positive 3x to the third. That was for there. And then we'll distribute to the far term. That gives us a positive, because negative times a negative is a positive, 4x squared. Okay. Here we have some monomials and trinomials. So we basically do it twice, or 3 times instead of 2 times. This is supposed to be 4x minus 5, or 4x plus 5 is over there. Okay. All right, so 4b squared times b to the third. That gives us 4b to the fifth. And we just add those exponents. And then 4b squared times 6b squared. Well, 4 times 6 is 24. And then b squared times b squared is b to the fourth. Just add those exponents. And then we do our final term. And we'll end up getting negative 4 times 3 is 12, b squared. Okay, so pause and see if you can do B or C. We'll distribute. That gives us 9u to the third minus 9 times 4 is 36, and u to the third times u to the fifth is u to the 8. So we just add those exponents. And then we'll distribute again. 9 times 1 is 9, so plus 9, and then u to the third times u is u to the fourth. Now notice here, these are not in highest to lowest exponents, so we just need to rewrite it as negative 36u to the 8 plus 9u to the fourth plus 9u to the third. And here C, distribute, that gives us 2x to the third, and then we distribute to the negative x, that gives us a negative x squared. And then x to times 5 is plus 5x. Okay. Multiplying expressions with more than one variable. All right, so here we have x's and y's. When you do this, you're just going to do one variable at a time. So here we'll distribute the x to basically to the x, so that gives us 3x squared y squared. And then we'll distribute here, that gives us negative 4x to the third y. So here we're just doing our x times x squared, gives us x to the third. All right, pause and see if you can do B and C. Okay, 4x times y, that gives us 4xy. And then we'll distribute to here. We have 4 times 5, well, that gives us 20. X times x gives you x squared. And then we just have a y squared. We don't have any, we can't distribute. There's nothing to distribute a y. So it will just stay the same as y squared. All right, next, last one, distribute this. 2 times 3 is 6. We've got an x squared and a y. We'll distribute here. Negative, or 2 times negative 2 gives you negative 4. X squared times x to the 5th gives you x to the 7th. And then y to the 3rd. Okay? If you have any questions on these, just let me know. Let's try some real-world applications. We've done ones just like this before. I think when we were using the distributive property and combining like terms, I don't know that we actually, I think this is just basically a review for this unit, or this lesson. It says a volleyball uniform costs $13 for the t-shirt, $9 for pants, and $8 for socks. Write 2 equivalent expressions for the total cost of 12 uniforms. All right, so basically we have 2 choices. We can add up all, like we can add the 13 and the 11 and the 8 to how much it costs for one uniform. So we could do that, 13 plus 11 plus 8, and then we could just multiply that by 12 to give us the cost for all of the uniforms. All right, but they want us to write down 2 equivalent expressions. So another way is we could figure out how much it costs for all the t-shirts. So 12 times 13, that would give us the cost for all the t-shirts. And then we could figure out the cost for all of the pants. And then we could add up all the cost for all of the socks. Okay? And then if you added those all together, then that would give us the same thing. All right, so basically going from the first and the second is you could just use the distributive property. All right, so those are 2 equivalent expressions, and then they also want us to find the cost. So you could use either expression because they give you the same. I would maybe recommend trying to use it both if you have time. So you could make sure that both of your expressions are equivalent. So here how we would do that is we would just add up 13 plus 11. That gives us 24. And then we'll add 8 to that. That gives us 32. So 12 times 32. And then you could probably do it on your calculator, or you could do it by hand. 12 times 32 gives us $384. If we did the other way, we'd do 12 times 13. That gives us 156 plus 12 times 11. That gives us 132 plus 12 times 8 gives you 96. Okay. So again, this kind of maybe, I mean, either way, they're both good, but this will tell us the total cost for the t-shirts, the total cost for the pants, and the total cost for the socks. That's what's right here. That's the cost for the t-shirts, cost for the pants, and cost for the socks. And then we can just add those together. 156 plus 132 plus 96 gives you the same thing, $384. Okay, and then the last one, Peter has 5 acres of land. Each acre costs X plus $6. Write an expression to show how much all of his land would cost. Okay, so 1 acre is X plus 6, but he has 5. So we would just multiply that by 5, and that would be an expression. Okay? You could also write another expression if you wanted to. It doesn't ask for it, but you could do it by distributing. You could do 5x plus 30. That would be another equivalent expression. Here we can't solve for the cost because we don't know what x is equal to. All right, if you have any questions, let me know, and we'll see you in class.